Okay, so here is our kinematics equation. D equals d sub I plus v sub I times t plus half of at squared. So depending on the problem, you might have to solve for any of these variables. I might give you the distance, the initial displacement, the velocity, the acceleration, and ask you for the time. I could give you the distance, initial displacement, and the acceleration in time, and ask you for velocity. So you should be comfortable solving for any of these variables, depending on what the problem asks you. So your first step should always be to draw out your sketch, make a list of knowns and unknowns, and your list of knowns should include everything that's given in the problem, and your unknowns is whatever you're looking for. So, if I wanted to solve for distance, that's pretty simple. The equation is already set up for me, just d. If I wanted to solve for the initial displacement, to solve for initial displacement, I would need to move d sub I to the left-hand side and move distance to the right-hand side. So I would just go ahead and subtract d sub I from both sides and get d minus d sub I. So get d minus d sub I equals v sub I times t plus half of at squared. I'd want to move d over to the right-hand side, so I would subtract d from both sides. So I would get negative d sub I equals v sub I times t plus half of at squared minus d. But my d sub I has a negative sign in front of that. So if I want to fix that, I need to go ahead and multiply everything by -1 on both sides. And so I would get, that would make d sub I positive. I would get d sub I equals negative v sub I times t minus, distributing the negative, half of at squared minus d, so plus d. So that's how I would solve for d sub I. And so I would go to my knowns and unknowns. My unknown would be d sub I. Hopefully everything else would be in my knowns, and I would just plug them in. So that's solving for d sub I. If I want to solve for v sub I, my initial velocity, so I've got some problem where I know how far it went, I know how fast it was accelerating, I want to figure out how fast it was going at the beginning of the problem. I want to figure out v sub I. Well, to isolate v sub I need to move everything except v sub I to the other side and get v sub I by itself. So I'm going to subtract half of at squared from both sides. And so that gives me d minus half of at squared equals d sub I plus v sub I times t. I want to get v sub I by itself, so I'm going to subtract d sub I from both sides to cancel that out. So I get d minus d sub I plus half of at squared equals v sub I times t. And then my final step, I want to get rid of t. So I'm going to divide both sides by t. And I get v sub I equals d minus d sub I plus half of at squared divided by t. I can simplify, I can move stuff around, I can do whatever algebra I'd like, but this will give me the initial velocity. Then all I'd need to do is just plug in my distance, my initial displacement, my acceleration, and my time. If instead I had my distance, my initial displacement, my initial velocity, and my time, and I was looking for acceleration, if I was looking for A, and do the exact same process, just some algebra, I'm going to move everything except A to the other side. So I'll be subtracting d sub I from both sides. I get d minus d sub I equals v sub I times t plus half of at squared. I want to get rid of everything except for a, so I'll subtract v sub I times t from both sides. And I get d minus d sub I minus v sub I times t equals half of at squared. I'm wanting to get rid of everything except for a, so I'm going to divide both sides by 1/2 t squared. And that will cancel out my half and my t squared. So I'll just have a all by itself, and I'll get a equals d minus d sub I minus v sub I times t divided by half of t squared. And I can do more algebra manipulation, move things around. For example, that half, if I'm dividing by a fraction, I'm multiplying by its inverse. So I could move that 2 up top and get 2 times d minus d sub I minus v sub I times t divided by t squared. These are just algebraic equations, so whatever manipulations I feel comfortable doing, I can do. All right. So that would be how I would solve for acceleration, given my distances, given my velocity, given my time. So the trickiest one, last one, I've got my time. Solving for time is a little trickier because we can see that time shows up twice in the problem. We've got v sub I times time and half of a times time squared. So we're going to have to write it in the form that we use the quadratic formula. The quadratic formula, if we might recall, if we have ax squared plus bx plus c equals 0, just by definition, x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So if I want to solve for time, I'm treating time like the x in this equation, and the coefficients, the things that are multiplying time, are the a, b, and c. So if I want to solve this equation, well, first I need to make it look like ax squared plus bx plus c equals 0. So I need it to equal 0. So I'm going to subtract d from both sides. And I get 0 equals d sub I minus d plus v sub I times t plus half of at squared. And I'm going to reorder that. Because it's addition, I can add numbers in whatever order I would like. So I'm going to reorder that so that it looks like the quadratic equation, ax squared plus bx plus c. So I'll put half of at squared. I'll move that to the front of the equation, plus v sub I times t plus d sub I minus d. And so I've organized it so it looks more like that quadratic equation. And so in this equation, half of acceleration is going to be taking the place of the a here, because it's multiplying t squared, just like this a is multiplying x squared. My b is going to be v sub I, because it's multiplying just the t to the first power. And then my leftovers that are not multiplying a t to any power, that d sub I minus d, that's going to act like my c. So I have to use the quadratic equation and basically just plug in stuff. So I have it matching up my equation up at the top right. So to solve for t is going to equal negative b. B in this case is what's multiplying the t by itself. So that's v sub I, negative v sub I, plus or minus the square root of b squared. Once again, b is v sub I, so v sub I squared, minus 4ac, so 4, and then our a in the formula is half of the acceleration. I know they both say a, but in this equation right here, the half of a, that's a as an acceleration. So I'll put half of a times c, and c is going to be my d sub I minus d. And then I plug in the bottom. The bottom is 2a, so 2 times our a, which is half of the acceleration. And so I should have all of these numbers in my knowns. I'd plug in my initial velocity, I'd plug in my acceleration, I'd plug in my distance and displacement, and that will spit out two numbers. Because keep in mind this plus and minus here, plus or minus. So I'm going to pick the one that gives me a time greater than 0. Time should be greater than 0. So I'll have to double check. I'll have to plug in both, checking for plus and minus. Whatever gives me positive times would be my correct answer. So just doing algebra, I should be able to solve my kinematics equation for any variable. Just given all of the other variables, I should be able to find any variable.